Hello everyone, today we're going to be working on fundamental problem 2.4, and this problem is asking us to determine the magnitude of the u component and also to determine the magnitude of the v component. So here we have our figure. Our v component is this one right here and our u component is right here. So the first thing that I like doing, as we do in every other video, is I like taking two forces that are given to us and drawing them off to the side. And once that we have those drawn off to the side, we're just going to draw this force right here on this side, and then we're going to take this force right here and draw it on this side. So that way, in the end, we get a parallelogram. And then from there, we're going to take a resultant force and we're going to draw that in. Okay, and from there, we're going to start filling in the information that we already know. As you could see here in the figure, it gives us that this angle right here is 30 degrees. So we're going to come and we're going to write that this angle is 30 degrees. And since we know that this angle is 30 degrees, we know therefore that this angle is also 30 degrees. And then from there, we know that the y-axis is right here. And this angle was given to us that it's 15 degrees. And we could tell that this right here is a right angle, meaning that it is 90 degrees. So what we could do to find this missing angle right here, because we know this angle is 15, this angle is 30. Find this angle, all we have to do is subtract these two angles from 90 degrees. And by doing that, we get that this angle right here is 45 degrees. And just like previously before, this angle and this angle are the same angles. So we know that this angle is also 45 degrees. Now that we know these two angles, the only angle that's missing are these two angles that once again are going to be the same angles. And to find that angle, we know that the sum of a parallelogram, the sides, the angles of a parallelogram, have to equal 360 degrees. So what we're going to do is we're going to take 360 degrees is equal to 45 plus 45 plus 30 plus 30. We forgot to give these ones, to label these ones. We're going to call those ones beta plus 2 betas. So we have 360 degrees is equal to 90 plus 60 plus 2 beta. 90 plus 60 is 90 plus 60 is 150 degrees plus 2 beta. 150 minus 360, that equals 210, giving us that beta is equal to 105 degrees. So these angles, both of these angles, are going to be 105 degrees. So now that we have that, how are we going to solve for components u and v? So what I like doing is I like writing on the side, what do we know? What are the knowns that we have in this problem? What is it that we're working with? So what we're working with is we know 3 angles. As we solved for earlier, we have these 3 angles that we solved for earlier. And what else do we know? We have one known side, which is our resultant force. And we have one side. So we have 3 angles and one side. So if there's one law, one equation that we could use to help us find the other 2 sides, because we want to think of this as like a triangle. We want to think of it as a triangle. This is a triangle. So we know one side of the triangle and we know the 3 angles of the triangle. So what could we use to find the other 2 sides? We could use the sine law to find the other 2 sides. So we're going to take the sine law to help us find the magnitude of the component u and v. So what we're going to do is we're going to write them which one do we have to solve for first? U. Okay. So we're going to write down here f of u over, so f of u, okay, we did not label. So we're going to label this real quick. This is u, this is u, this is v, and this is v. So this is our u. We're going to look at this triangle right here. Okay, we're going to work with this side of the parallelogram. So our u is right here. So the opposite angle to this side is the 45-degree angle. So we're going to, so f of u over sine of 45 degrees. And then the other side has to be some a side and an angle that we know. So then from there, what we're going to do is we're going to take this side, since it's the given resultant force, and we're going to take its opposite angle. And I did not write it, but I did not write it in the thing, but our resultant force was of 30 pounds. So then what we write here is 30 pounds over sine of 105. From there, all we have to do is we gotta solve for f of u. So f of u is equal to sine of 45 times 30 pounds all over sine of 105. You plug that into your calculator, and once again, your calculator has to be in degrees, and that should give you that f of u is equal to 21.96 pounds. And just like that, we found our magnitude of our component u. And we're going to do the exact same thing for our v component. So off here to the side, we're going to do f of v. And we're going to come over here back to our little figure. F of v is this one right here. So it's this side. And we're going to look at the opposite angle to it, which is the 30 degrees. So we have f of v over sine of the 30 degrees. And then again, we're going to use our resultant force and its opposite angle, which was 30 pounds over sine of 105. And again, we're simply going to solve for f of v. So we have sine of 30 times 30 pounds all over sine of 105. We plug that into our calculator. That should be in degrees. And that should give us 15.52 pounds. And that is our magnitude of our V component. And just like that, with knowing 3 angles and 1 side, we were able to use the sine law to help us determine the magnitude of the U and V component, giving us F of U equaling 21.96 pounds and F of V being 15.52 pounds.